So in this video, we've already talked about how to do the calculations for a regular simple gear train. We're now going to go ahead and take a look at how to deal with a compound gear train. Okay? So for us to look at a compound gear train, okay, we're going to start kind of the same way. Let's talk about the math first. So in this case, we're going to go kind of in the opposite order. Okay? So we'll say that we have 12 teeth in the driver, we have 36 teeth in the second gear. The second gear will share with a third gear. These will be a compound. This will be where kind of we have that compound case. So we'll say that that's 60 teeth, and then we'll have that same 84 teeth at the end. Okay, so it's good to go ahead and kind of keep the units in there, just even if it's an imaginary unit, the teeth. But the calculations are pretty much the same case. Okay, it's a good idea to go ahead and start off and set up the initial fraction. Okay, so the number of teeth out over number of teeth in. Okay, so 36 teeth over 12. These are both multiplications of 12. So this is 3-to-1 ratio. The second one is 84 teeth over the 60 teeth, or we can kind of remember from before, that's the 7-to-5 ratio. Okay. The gear ratio is pretty much going to be the same case. Okay. Divide those. 3 divided by 1 means that we have an actual 3-to-1 ratio, or we may see it as just 3. For this, we may go ahead and pull out the calculator. 7 divided by 5. Okay. And that is either written as 7 to 5, because those won't simplify down, or we could have it as 1/4 to 1 ratio, or we could simply have it as 1.4. Okay. Going back to the fraction mode, finish the calculation. 3/1 times 7/5. That's going to be 21/5, or if we simplified that down, okay, that actually would not simplify down, so we could keep it as the 21/5, or we could go ahead and run the calculation, and we would know that the approximate ratio would be about 4.2. To 1 ratio. Basically saying that for the output to make its 1 rotation, this will have to rotate 4.2 times, okay, or about 4 1/5 of rotation. So now we go ahead and head back over into our gear generator and run the setup. Okay, so first gear, we can go ahead and put in the numbers first. We know that the teeth count on this one is going to be 12. We know the teeth count on this one is 36. We know the teeth count for this one, 60. And the last one, because we've basically flipped the system, is 84. Okay, so this takes care of the values. Okay. But we need to go ahead and recognize that number 2 will be sharing an axle with the first one. Okay? So we have to be a little bit mindful of which one we're going to say is going to be sharing the axial connector with its parent gear. Okay? In this case, our C gear is sharing the axle with its parent, the number 1 gear. So we go ahead and tell it to share the axial connector. And while that kind of hides the stuff underneath it, okay, we are still able to go ahead and kind of see how that's fitting together. Okay. So this may not be the most practical to physically build, but we can still kind of see what's going on with the first gear. Okay, so we see that it's rotation. You know, let's speed this up. Okay, so if it just made one rotation, okay, actually we may want to pay more attention to kind of the bigger one. Okay, but because it's not a perfectly matched system, okay, so we notice it's on top. It's on top. Okay, so in theory, this will make one rotation if this makes, you know, and I know it's a little hard to see, but if that makes the 4.2 rotations, okay, so 4.2 would be 4 full rotations and then finishing about here. So let's restart. So 1 full rotation, 2 full rotations, 3, 4, and if you were paying attention, that it made its full rotation. Okay, so again, our math is checking out. Okay, both what we have on paper as well as some of the internal calculators that the software has. So you may pay attention and notice that the ratio on the first one, okay, going back to our original parent, okay, the first gear in our chain, the driver, we're getting that same 4.2 calculation that we did on paper. Okay, so again, the gear simulator is a good way of kind of playing around with these systems. It's a good way to go ahead and verify your calculations. It is not to make place of your calculations. This is not software that you'll get to use on a quiz, an exam, or on a test, but it is a tool to help you verify that you know the mathematics that's going into these problems. So, like with this video, it's a tool to help you out, and if you need more help, of course, leave questions, comments, concerns. You can email me or you can leave comments, and you know, this is just another tool to help you move along, especially in a time of virtual learning.